the formation of this, you're dealing with atoms. So you have to draw the Lewis structure for the atoms. So hydrogen only needs one more electron. Sulfur needs two more. So if this hydrogen bonds with this electron, hydrogen gets its extra electron. Now it's got two. And this one is still short, so we need two of them. You need two hydrogens. This one's going to bond here. This one's going to bond here. So don't forget, each one of these sticks represents two electrons. Okay? Two electrons. And that's all I'm asking for a question like that. So if I say draw the Lewis structure for H2S, you would just show this. If I say show the formation using Lewis structures, you would do the whole thing. But today I'm actually going to show you how to do the Lewis structures for covalent compounds. Okay? I don't think the 12s have to do this question, right? So if you didn't have to do this question, put your pens down, just relax, just watch. We don't talk. Okay, so grade 11s. H3O plus. Do we know any other common compound that's got hydrogen and oxygen in it? H2O. Thanks, Josh. H2O. If you do the Lewis structure for H2O, it looks like this. The difference between these two entities, these two things, is a hydrogen with a plus charge. Hydrogen with a plus charge. How many electrons does a hydrogen with a plus charge have? 0. None. Nada. Zilch. So, this is telling us, though, it's made a bond. What do you call a bond where one atom donates both electrons? Say it, Zach. Say it, Zach Brown. Coordinate covalent. Coordinate covalent bond. So, to draw the Lewis structure for coordinate covalent, that hydrogen ion is make it eyes and one of these lone pairs. So you make H3O plus. You can draw it like this. Remember we said you can draw a bond as two electrons between two atoms? Or like that. Either one of these is acceptable. Both are correct. Okay, both of these are correct. Yeah?
So you draw
So this lone pair is now represented by that stick. Yeah. Okay? That stick. Now, B, I think, was what types of bonds? Name the bonds. What type of bonds do we have? Are they ionic or covalent? No. covalent. We've got a coordinate covalent bond. We've got one of them, and the other two are covalent. Oh, that's like saying an apple is an orange. They're right? Ionic and covalent, you're either one or the other. Okay. Non-polar covalent or polar covalent? How do you figure that out? What should you be doing if I ask you, is it non-polar or polar covalent? You need your periodic table, you need your electronegativities. So, what's the difference in electronegativity between oxygen and hydrogen? Saeed? What's the difference? Okay, don't listen to him. 1.4. So it's a polar covalent bond. So we have two polar covalent bonds. But ideally, we don't know which one's which. They have the same bond length. They have the same strength. One of these is not stronger than the other. Okay? They're just covalent bonds. One's coordinate covalent, two are polar covalent. They're all covalent. Can't tell which one's which if we take an X-ray of that structure. Last question.
What kinds of bonds is the iron likely to form with other entities?
Ah, nice. Saeed, you hear this? What kinds of bonds is this ion going to form with other entities? Ionic, you got it. Ionic. It's going to form ionic bonds, which is, I think, what Saeed meant earlier. This can make ionic bonds now. Have you heard the term entities ever? Because I'll use it. It's just a scientific sounding name for stuff. It's going to make ionic bonds with other stuff. Okay? That's all it means. Just other things. All right. There's question 14. Okay? The metal gives up the valence electrons to the nonmetal. If there's a different number, you have to have more than one, but it'll tell you in the formula how many of each atom. I've done a 1-to-1 and a 2-to-2. So you know you need only one of each. Does that help? Everybody knows how to do an ionic glue structure now. Yes. You guys should feel proud. Correct. All the halogens only want one more electron. Who else? Frequently used in examples. It's kind of separate from everybody else in the periodic table. Hydrogen only wants one. So, this is how many electrons you still need. So this is how many bonds you have to make together. Okay? Who only wants two more electrons? Who wants two? Come on, don't be shy. Who wants to get two? Caleb? Give me an example. Oxygen. No, it's okay what you said. Okay, oxygen only wants two more electrons. Who else? Sulfur. Is there anybody underneath them? Selenium? Okay, we're going to leave selenium where it is. Okay, 3. Who wants to make 3 bonds? Saeed? Specifically, not all of them. Nitrogen does, yeah. Nitrogen and phosphorus do. There's one other element that's not in that row. I told you is an exception to the octet rule. Rhymes with moron. Boron. Okay, boron. Who wants to make 4 bonds? Who? I couldn't hear you. You didn't say anything. I think you're right. Carbon. Who else? Silicon. Okay. This is really going to help you when we start doing Lewis structures for covalent compounds. Because you're not now going to put 5 bonds on a carbon. Maximum number will be 4. Okay? Maximum number for carbon will be 4. Maximum for 3, unless it's a coordinate covalent, will be 3. Okay. Something else I want you to think about. Central atoms. So if you have 3 atoms in a row, which one do you think is the central atom? Middle one. Yeah, the middle one is your central atom. The one with the highest combining capacity will be your central atom. Okay? So the one with the highest combining capacity will be a central atom. You can have more than one central atom if you've got more than 3 atoms. Who will never be a central atom? Look at your list. Who can never be in the middle? Hydrogen. Only makes 1 bond. If you're in the middle, that means you've got to make 2. So, if you've got a combining capacity of 1, you will never be in the middle, ever. Okay. These are the same 2 compounds. These are both ethanol. Okay? These are the things older people drink on the weekend. Ethanol. This is the alcohol you can consume. Although all alcohol is toxic in some degree. Okay? All alcohol is toxic. Which is why if you drink too much, you get sick and it can actually kill you. Okay? So, the difference here you've got 2 carbons, 5 hydrogens, and an OH. 2 carbons, 5 hydrogens, and an OH. So this formula is actually telling you that you have a carbon, then a carbon, then an oxygen. Hydrogens always go around the outside. Okay? Hydrogen's always on the outside, so this is your center. These are your central atoms. So when you see them in a list like that, it's actually telling you the order in which they're bonded. If you see it like this, they're not telling you anything, except who's there. I'm going to show you how to do Lewis structures for covalent compounds from scratch. Okay? So each hydrogen brings 1. Oxygen, 6. So total, we have 8 electrons to place. So what you have to do is put down your central atom. It's the one with the highest combining capacity, so that is oxygen. There's your two terminal atoms. Put a bond from each hydrogen to the oxygen. Now we've got covalent bonds. How many does each bond use? How many electrons? 2. So how many bonds have we formed? 2. So we've used up a total of 4. See, math's pretty good here. 4 electrons. That leaves 4 left to place. So it says put them around your terminal atoms first. Well, how many does hydrogen want? 2. It's already got 2. It's got 2 in the bond. So hydrogen is done. Which now leaves oxygen. So if you place them around the terminal atoms, you have some left over, you put them on the central atom. We've got 4 electrons left. There you go. Now I have none left over. So now, double check. I've got 2 here, 2 here, 4 here. Total of 8 electrons. Total of 8 electrons. Oxygen is surrounded by 8 electrons. Its octet is full. Each hydrogen surrounded by 2. Done. There you go. There's your Lewis structure.
How would we know, besides us already knowing that the H's go on the one side?
Because now you know, I've told you.
But there's no way of us being able to.
Not yet.
This one knows that.
No.
So we'll always be told, or told previous to
Oxygen is always going to bend.
oxygen, whatever.
Oxygen's always going to bend. Okay, OF2. OF2. Oxygen still brings 6. How much does fluorine bring? 7. There's 2 of them. So it brings a total of 14. So now we have 20 electrons to play with. 20 electrons. Who's got the largest combining capacity? Oxygen, so it's our central atom again. By placing our bonds, we've done 2 bonds, we've used up 4 electrons. That leaves us with 16. How many more do our terminal fluorines need to satisfy their octet? 6, because there's 2 there. So put in 6 on each one. Now, each fluorine is surrounded by 8 electrons. So 6 times 2 leaves us with 4 electrons. Put them on the central atom. They're left over, put them on the central atom. There you go. Oxygen now is surrounded by 8. We've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 electrons. Okay? Ready for one more? CO2. Carbon's got the highest combining capacity, so it's in the middle. Next step says subtract your bonding electrons. 2 bonds, 4 electrons. So we have 12 electrons left. It says stick them around your outside, your terminal atoms, to complete their octet. Each oxygen currently has 2. They want 8. They need 6 more. We've got 0 electrons left, but we have a problem. Our carbon only has 4 electrons, but it wants 8. Zach? Do a double bond, yes. What you do if you're short, this is the next step in your instructions. Number 7, if the central atom does not have a full octet, convert 1 or more pairs to a double or triple bond. So, if I take these, move them between the 2, that gives carbon 6. If I do it on this side, it's going to make 8. So I have used a total of 2, 4, 6, 8, 10, 12, 14, 16 electrons. That's good. That's how many we had. Oxygen on the left, surrounded by 8. Oxygen on the right, surrounded by 8. Carbon in the middle, surrounded by 8. Okay, homework. I would like you to do page 81, 13A, B, and E. We will do more of this tomorrow in class.